tables, functions, that looks ugly. Functions, and graphs. And actually, these are three of the same thing. They're three different ways of representing the same thing. Okay. Give me 1 second. Okay, so let's look at what function tables are. And we've looked at tables before. And what I mean by tables, we mean this idea of this X and Y idea here, where we have an input and an output. But math is all about representing things in different ways because we can use it for different things. Like this could be a dates on a history table. This could be points on a map. This could be temperature of global warming, right? So we can use this to represent a lot of different things. So for us, our input and output are super important. So let's take a look at a couple of things here. If I give you guys some values, 1, 2, 3, let's do 3, 6, and 5, 10. Okay. Well, these can be represented by what we call an ordered pairs. Oops, that looks ugly again. Ordered pairs. And so when X and Y, X is 1, Y is 2. That's what the table said. When X is 3, Y is 6. Again, that's what the table said. And X is 5, Y is 10. And these are just points. Points on a graph. Well, let's take a look at a graph now. If we start with 0, 0 in the corner, and we generally call this X in the horizontal and Y in the vertical. So when X is 1, Y is 2. Put a dot. And it's almost like you're zeroing in, you're targeting something. If X is 1, Y is 2. X is 1, Y is 2. Put a dot there. X is 3, Y is 6. 2, 3, 4, 5, 6. Put a dot. Okay. And X is 5. Y is 10. 7, 8, 9, 10. Okay. So these are just 3 points for us. But input and outputs, this is just 3 glimpses into this pattern. Let me give you an example. Imagine if your mom is calling to ask you where you're at. She wants to track you, right? So what does she do? She could call you and say, hey, where you at? But she can't track you all the time. It's just 3 different glimpses. She can call you 3 times, kind of figure out where you're at. Even GPS trackers, they're not always constant. There's some time delay. There's like, it checks every 30 seconds. It checks every minute. It never checks every second. It would kill your batteries actually. So we end up seeing this idea of a trend, and then that's where lines come in. When we draw lines, this line here goes through all the points. Oops, I missed that one a little bit. Let me undo that. This is going to lead us to what we're drawing eventually, which is in this chapter, this idea of a line graph. Okay. And this line goes through all the points. It went through 1, 2, it went through 3, 6, and also went through 5, 10. But it also points out some interesting facts, is that it goes through all the points in between also. It goes to 2, it goes to 4, it goes through all the decimals in between. And the idea of a line is actually, it's a line, but it's made up of a lot of tiny points. So this is kind of our point that we're going to get to later, is that sure, we can glimpse at 1, 3, 5. At 1, 3, 5, our answers are 2, 6, 8. But what about at 2? What would that look like? What about 4? What would that look like? And a line is a representation of all those possible answers. Now, another example is this, is if you guys ever look at a map of, say, GPS tracking again, and it shows you points, boop, 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 like at 1 o'clock, at 2 o'clock, and at 4 o'clock, it shows you 3 different points on the map. Great, but that doesn't tell you about any of the points in between. So maybe it was like this. You're traveling around LA, and these are just 3 points along the way. So our goal is to start to create images, approximations, lines specifically that will go through these points. And in algebra, we end up with something called a function. That's a relationship that connect all those 3 points together. Okay, we're looking at climate change oftentimes, and you see climate change of dates, and we have temperatures. And you'll see dots, patterns. You guys ever see this? And then scientists are trying to figure out a line that would best fit that approximation. Given all those dates, they don't form an exact line, and we want to make a model of a line that would make it kind of best fit. It's called the best fit line. Okay. So we want to be able to read tables, read points, read graphs, and also read functions, which is our ultimate goal, is to write that function that represents these points. Now, for this problem here, okay, so let's move on. So let's write y as f of x. We mentioned in our last class that y and f of x are the same thing. It's just a different way of writing something. So let's create a new table today, and f of x, okay? But this time, f of x is going to be the equation 2x plus 1. So I want us to go ahead and plug in some values. We'll plug in -2, -1, 0, 1, and 2. Okay. Now, just a reminder, f of x is just another way of saying y. It's exactly the same thing. It's our output value. Now, why do we write something as f of x? Well, the big deal here is transparency. I could see what I'm plugging in. F of x is 2x plus 1. 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 So here's what we're doing here. This is our fast way of writing it. But if we didn't have tables, you would write this: f at -2 is equal to 2x plus 1, -2. And you would write again, -1 equals to 2, -1 plus 1. F of 0 is 2, 0 plus 1. Is that any different than us writing it in the table? No. Tables are a way for us to organize information in a nice, pretty form. And if you ever write standards before, tables allow us to do that. 2, 2, 2, 2, 2, parentheses, 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 right? And we're just going to plug in the numbers like what we did here. -2, x is now -2. X is now -1. X is now 0. X is now 1. X is now 2. This is equal to our results. -2 times 2 is -4, plus 1 is -3, because I have more negatives. -2 plus 1 is -1, because I have more negatives. 0 plus 1, how did I get 0? Because 2 times 0 is 0. 0 plus 1 is 1. 2 times 1 is 2, plus 1 is 3. And 4 plus 1 is 5. So from here, you could graph it, but you know what? I'm going to draw the relationship. Let's write the ordered pair version. Ordered pairs. When x is -2, y is -3. When x is -1, y is -1. When x is 0, y is 1. When x is 1, y is 3. And when x is 2, y is 5. I'm just copying all this information here. And now we're switching to a different mode now. Let's go ahead and graph these points. At -2. Try to make your tick marks as best as possible, even as possible. It does help your graph a lot. If you guys are using line paper, it does make it a little bit easier, I think. So -2, -1, 1, 2. If you want to save time, you can graph every other. You can graph 2, 4, 6, 8. See, 2, 4, -2, -4. Okay, every tick mark is one mark for us. So let's graph our points. At -2, -3. That would be right here, ish, right? -2, -3. Our next point is going to be -1, -1. Our next point, it would be 0, x is 0, y is 1. Okay, let me show you that one more time. How did I do that? X is 0, but y is 1, so we have to go up one space. We have x is 1, y is 3. 1, 3. And x is 2, y is 5. Now look at all those dots in a row. Okay, look at all those dots in a row. What type of shape does it form? Hopefully you're going to say a line. And your line might not be the straightest. My line's not the straightest for sure. But the idea of this line, it's all the possible solutions. So we have 5 points here. But what if I wanted to plug in 1.1? What if I want to plug in 1.5? What if I want to plug in 2.5, right? So a line is actually made up of all the tiny points for every x and y value. So my question to you is, would you rather just draw a line or a million tiny points? You, of course, rather just draw a line. But that's what a line is. It's all the values that are representative of this function. That's what the function looks like. So if I plug in 0.5, 2, 0.5 plus 1, what's 50 cents times 2? That's 1. 1 plus 1 is 2. And I can't zoom in, but at 0.5, we're at 2. Thank you, Guadalupe. It's a line. And in algebra, we're going to work with lines. We're going to work with V's. These are absolute value graphs. We're going to work with parabolas. Okay. In algebra 2, you start to do circles and what we call hyperbolas or ellipses. In geometry, you deal with triangles, and you'll look at equations for triangles too. So in a sense, we're looking at the world around us, and we're trying to write math into it so we can make it predictable. Now, here's something about this equation, 2x plus 1. Imagine if this was money or some type of investment. What happens if I stuck 100 here? We could, on the graph, theoretically go all the way to 100 and see this graph take off. But the cool thing about our function is that we don't have to look at the graph. It's 2 times 100. It's 201. So we can make predictions of what value should be. We can look at the function. We can look at the graph. Okay. So what else do I want to go over? So pretty much this is the idea of what we're doing for your IXL homework. You're going to look at graphs, you're going to look at points, and you're going to write them out in a table. Okay? Look at graphs, look at tables, and we're going to go back and forth with them. So I'm going to give you guys this last step. Let's do it one more time. If f of x is equal to, let's do 1/2 x plus 2. Okay. I want you guys to give me some easy numbers in the chat. What number should I use for x to make this easy for us to solve? In the chat, go ahead and tell me what number should I plug in to make this an easy problem for us to solve. I'm hearing 1. Sure, I can do 1. Okay, 3. Okay, I'll take it. Do you guys like dividing 1 and 3 by 2? What number would be easy for you to divide by 2? What number would be easy for you to divide by 2? I hear 4. Yeah, great. I would take 4. So I'm going to give you guys another table here. And I see 4, 6. Good. What's an easy one? I see 10. 10 is good. 2. Thank you. Great. So I'm going to give us some values here. And we're going to look at the meh chart and the easy chart. So the cool thing is that if you can think 2 steps ahead, the problem becomes a lot easier on you. So on these tables, you can oftentimes pick whatever numbers you want, okay? Because it's for us to figure out what's going on here. So if I pick 1, so 1/2, 1 plus 2. 1/2 times 1 is just 1/2. So it's 1/2 plus 2. What's 50 cents plus 2? That's 2.50, right? Or 2.5. Man, there's a fraction there. Nah. 1/2 times 3 plus 2. That's 3/2. 3/2 is the same as $1.50. $1.50 plus $2 is $3.50. So I'm pretty sure you agree with me. You don't like the fractions. Not as much. But what if I wrote 1/2 times 2? Isn't that just 1? What's 1/2 times 4? What's 4 divided by 2? 2. Oh, I like that whole number. What is 1/2 times 6? What's 6 divided by 2? Ooh, 3. I like that. What's 1/2 times 8? Well, that's 4. And if you choose the right number, especially for this fraction you're going to multiply by, you save so much time. 3, 4, 5, 6. Okay. So one thing I wanted to bring up is that, sure, this is a function and you can plug in whatever numbers you want. But if we take just a moment to think about what could save me time, hey, especially I don't like the fraction. If I multiply a number that would cancel out that fraction, perfect. 2, 4, 6, 8 cancel out, divide by 2. Okay. So our next step here is to now graph it. Very quickly, I'm going to graph a couple of these points. So let's graph the easy points, right? Because do you guys really want to graph the fractions? If I don't have to, I don't want to. So 1, 2, 1, 2, 3. 2, 3. 4, 4. 6, 5. Now, I want to show you something kind of cool because we also did some extra work here. We did 1 and 3, right? So at 1, here's 1 and here's 3. If I look at the graph, isn't that 2.5? Because it's between 2 and 3. At 3, doesn't that look like, 3.5? Right? That's what we said it was, right? So the idea is all these points, when we plug them in, give us actual values to the graph. Not all of them are nice whole numbers, but if you want to do the work, you can find what all these values would be. Eventually, we're going to go backwards. I'm going to say, hey, here's a point. What's the x value? If I tell you the y, what's the x value? So going forward and backwards, being able to manipulate these problems in any way we need to is part of this idea of algebra. Moving numbers, solving for variables, and those variables could be x's or y's. Okay. Let's go ahead and take a look at your IXL homework for today. Okay, let's take a look at this problem here. Let's do a screenshot. Okay, so the table is already drawn for us. I'm gonna just write again here so you have a little more space. And they tell us the function is right here. F of x is equal to 2x. Okay, and they gave us problems, values 0, 1, and 4. 0, 1, and 4. So 2 times 0, 2 times 1, 2 times 4. If you write like standards, it's actually not that much time. If you notice, I first wrote the function with a blank. If you remember, I just wrote that empty. I'm just doing the same thing over and over and over and over and over again. And then I can plug in 0, 1, and 2 really quick. So 2 times 0 is 0, 2 times 1 is 2, and 2 times 2 is 4. So on your graph, you want to graph 0, 0, 1, 2, and 4, 4. 1, 2, 3, 4, 1, 2, 3, 4. Whoops, I messed up here. This is 0, 0, 1, 2. Oh. Oh, then, oh, I messed up. Sorry. Gosh, that should have been a 4. Haha, that's 8. I wonder who was screaming, Mr. Co. 8's up here. Okay, this is going to represent a line for us. So 0, 2, and 8. 0, 2, and 8. And they also want us to click on the points. 0, 2, 1 is 2, and 4 is 8. Oh yeah, 4 is 8. So all those points fall on the same line. Okay, so do the same thing here. We're going to plug it in. We can do mental math if you want. If I plug in 0 into this problem here, 2 times 0 is 0. 0 plus 6 is 6. Plug in 1. 2 times 1 is 2. 2 plus 6 is 8. 2 times 2 is 4. 4 plus 6, 4 plus 6 is 10. 0, 6, and 1, 8. And just to verify, 2, 10. Yeah, 2, 10. Okay. So your homework is really just, there's going to be 3 sections. I asked you guys, I think, to do just to a SMART score of 70. So it shouldn't take you that much time today, okay? And we're just practicing tables, graphs, and ordered pairs. And we'll get to the relationship more with functions when I see you guys next week.